Dear students, I welcome you all for this online session wherein I will be briefing you about how we can able to perform experiment on DC servo motor kit which is available in our control system laboratory and to study the speed torque characteristics of DC servo motor. So basically, you might have come across about so many DC motor which is primarily used in industries. If the DC motor is used in control system, we call it as DC servo motor, wherein the rotor inertia will be very small. As a result, the motor will have a high torque to inertia ratio, which is commercially available in most of the DC motors. And here the DC servo motor will give maximum acceleration for variety of application, and the performance of servo motor which can be used as a brake is also satisfactory in most of the applications. So primarily the kit which is available in our laboratory is of permanent magnet type of 24 volts DC, and the maximum speed it can reach about 4500 rpm. So coming to the outline of the session wherein I will be covering the objective of the experiment, apparatus required, circuit diagram, procedure, tabular column and demo of the experiment. So coming to the objective, the primary reason of keeping DC servo motor experiment in control system laboratory is to learn the characteristic curve of how the DC servo motor will behave under various voltage and to obtain its performance curve. Coming to the apparatus, so we do have a DC servo motor kit, patch cards, ammeter. So this is the kit which is available in our laboratory, and you can load the DC servo motor using this spring balance. You can note down the values of what is the weight you are applying to the brake drum of the DC servo motor shaft which is connected to the brake drum, and they had given the control switch for turning on and turning off of the DC servo motor. So this is the top view wherein you can observe the motor, and these are the electronic circuits for the conversion analog to digital to display the speed as well as the current. So moving on, so this is the circuit diagram of the DC servo motor. You can observe this is the DC servo motor which is connected, the shaft of the DC servo motor is connected to the brake drum where you will apply the load using this spring balance by tightening the overhead, and the kit will display the speed in rpm and also the amps, and here they had used the photo radioactive sensor to sense the speed as well as the various parameters. So overall you can observe that the servo motor has a control switch to turn on and turn off, and also when it comes to load, here we will load the brake drum of the DC servo motor. So coming to the specification, as I told earlier, the type is permanent magnet, maximum voltage is 24 and the torque is around 400 gram per centimeter, and the speed it can reach up to 4400 rpm. So moving on to the procedure, so you should know all the nameplate detail and the working principle of DC servo motor in order to conduct an experiment on this. Make sure that the load is removed while turning on the DC servo motor, and note on the no load reading, and by turning on the servo motor. So you can set it for 24 volts rated, and then you can change the rated voltage by adjusting the speed potentiometer which is provided for the different voltage reading for 60% and 40%. And you can apply the load in steps for the different rated voltage what you have set it for 24 volts, 16.4 volts or 14.4 volts for 60% or 70% or 40%. So like this, in our laboratory we give for different trials, that is 60% and 40% and 100% of the rated voltage, but in general the students can do it for the 50%, 30% just to observe its speed torque characteristics for the different voltage. And you can upload the case studies and you can observe in the virtual lab also how does the DC servo motor can behave. But since the kit is available in our laboratory wherein you can simulate by adding the load to the kit, so that you can just draw the inference from the virtual lab reading also, as well as the really how does the DC servo motor will behave. And you can go up to 0.8 amps, do not exceed up to 0.8 amps, beyond that you can't able to load. So that is one of the constraint about the kit which is available in our laboratory. At each load you need to note down the speed, torque and the spring balance reading, and you can consider W1 and W2 based on your reference, and always you need to subtract the higher value from lower value. So calculate the corresponding torque and plot the speed torque characteristics, and you can do it for different set of values as I told earlier, 60%, 50%, 30%, and you can observe the how does the curve will change for the different control voltages. And this is the tabular column wherein for the set voltage you need to note down here for the different case studies. IA is the armature current which will display on the kit itself and the speed, and W1, W2 you need to note down with a scale which has been already marked on the spring balance, and total weight you can calculate. Always consider the higher value from, subtract higher value from lower value scale what you had already tabulated in the table. And the torque will be T is equal to W into R. R is the radius of the breakdown. So for that you need to measure the circumference, that is 2 pi R. You will get from that you need to calculate R. So in our laboratory you can measure and you can obtain the value. So this is the typical graph wherein you can obtain for the speed versus torque. You can observe it is linearly decreasing. The speed will decrease for increasing in torque. So now we will go to the demo of the experiment. Dear students, I welcome you all for this DC servo motor speed torque characteristic experiment demo, wherein I will give you a few inputs as well as how does the DC servo motor characteristics can be obtained by using the module which is available in our control system laboratory. Now let me give a few input about DC servo motor, wherein the characteristics as well as the construction is almost similar to the DC motor constructions, and wherein here in our laboratory the DC servo motor is of 24 volts, and we will perform for 100%, 60% and 40% of the rated voltage, that is 24 volts, 14.4 and 9.2 volts, wherein we will record the speed and we will apply the load by using this spring balance, wherein actually the load will be applied through the breakdown of the shaft of the DC servo motor. As you know already in our electrical machine laboratories, wherein you already computed so many experiments related to DC shunt machines, once the load is applied, the load current will increase and the speed will be reduced. So that we will able to tabulate for the different case studies, and we can able to obtain the graph, expected graph. Okay, so now let me switch on the kit and give you so now I have energized this module. You can observe I have not turned on the servo motor. Okay, so here we need to measure the voltage. So you can able to measure the voltage across the armature of the servo motor using this multimeter, and let me connect the multimeter across this armature to record the voltage. So once I energize the servo motor, you can see the no load current, also the what is the voltage. So the currently the voltage is around 3.5 volts. We can set it for the voltage up to 24 volts, and this is the RPM which will be displayed in the LCD, where it has an inbuilt digital tachometer which will sense the speed of the servo motor and it will display. So now by varying the speed of a servo motor, I can completely excite up to 24 volts, so which is the rated voltage of this. So you can observe the RPM as well as the current also will increase in line if I increase the speed. So let me set it for the 24 volts. So the rated voltage is 24. So now I had set it for 24 volts. So you can note down the no load reading. So the RPM is 4586 and the no load current is 0.130. So now I am applying the load by tightening the spring balance using the kit which is available here. So you can observe the speed has reduced, so it is 4240 and the current is 0.312. So similarly you can record the value here. 1 division is equivalent to 5, so you can record this as W1 and this as W2. So currently it is reading around W2 is 50 and this is around 15. Okay, so you can note down in the tabular column which is provided, and meanwhile you can continue with the loading for the different current. So you can vary up to 0.8. Okay, so now you can observe. So I set it for 0.569 and the load here is 130 W2 and W1 is 30. Okay, 35. So you can tabulate this and you can compute for the remaining reading. So this is one trial, and similarly if you want to do it for different voltage characteristics, so you can observe the RPM also which has been reduced on applying the load, and wherein if I set it for the voltage, DC voltage across the DC servo motor in order to record, now it is 24, the voltage remains constant. So you can set it for 14.2 or 9.2. So based on the rated voltage which is 24 volts, so for 60 and 40% by reducing the speed. So you can do it for that trials, and what I want student to learn is, so need not to be only for 60%, 40%, you can set it for 50 and 30% also. So using this study module we can able to learn how the speed versus torque can be obtained. And one more thing, in order to calculate torque we should know the radius. So here how to calculate a radius, so let me tell. So this is the brake drum. Hold on a wire where just place it on this brake drum which will give you the circumference, which is 2 pi r, and calculate r. So that r can be used in order to calculate the torque, because that is very much important in order to plot speed versus torque characteristics. So with this I will be signing off how we can able to conduct a experiment using the kit which is available in our library. Thank you. I hope you have observed the conduction of DC servo motor, and you can able to simulate for the different set values. So with this, I will be closing the session. Thank you.